Dear students, today's lecture is about ocean circulations. In this lecture, we are going to discuss and we will know about the ocean circulations. What actually are ocean circulations are ocean currents, are movements. Then we will discuss and we know about the types of ocean circulations or currents, general factors causing surface currents, also the other kind of currents are there types. Ocean currents and climate. What will be the effect and interaction or relation between the ocean currents or the circulations and the effect on the regional areas climate? So let's start from the first from the ocean circulation. What actually are ocean circulations or currents? Ocean circulations or currents are actually moving seawater. Here you can see the swell type of water here in the ocean. So actually the ocean circulations are the moving water that's at the soil farm or well farm and transfer it from warm to cool areas. It is the function, natural phenomena or processes from the pressure and heat to the surface and the regional topographies and geography of the oceans, because we know that major part of our globe is water, so it helps in equal distribution of it across the globe. These also are similar to the pattern of major wind belts, like we know there and globally there are the wind belts or the surface of the seas also in the drier areas. So these surface ocean or surface currents are actually similar to the winds that blow over the surface. So here if we see that ocean and the swirl type of gyre, actually it is that also affect coastal climates. This is the function of ocean currents or circulations. These currents are circular motions of the ocean of water are actually in all the major oceans are a gyre. That's all. It's also called a gyre. Here if you look at that picture and a view and a focus view, you will see the swell type of or vortex type of water. Actually, what's a gyre? Here I have mentioned it's a circular spiral well form, and it refers to the circular motion of water in all the major oceans, and it is centered in the subtropical high pressure regions. But that I have mentioned in the tropical, the areas which is near some areas to the tropic of Capricorn or tropic of Cancer. So the tropical areas next to the equator, the regions of thus area oceans have high pressure. Due to the high pressure, these kind of water become swirl and vortex are formed. That's the gyre. So these leads to the circular motion or circular currents, which leads to the movement of water or flow of water, a transfer of water from one regions or region of that area or oceans to the next or other far away oceans. So that also then help in the distribution of surface heat or surface heat budget regulation around the globe. We will discuss how the types of ocean circulation or currents are there, how many surface circulation or surface currents are found or being occurred over the globe. Here first we can look at that picture which I have here mentioned. The warm or shallow currents will mostly at the surface type, that's why they are called shallow. And but the cold and salty deep currents, that's because of the salinity and the density, they will dense, and that will go to, they will obviously cool, then they will go toward the deep side of the ocean. But the warmer they are, warmer the currents are, warmer the water surface are, then they will be shallow currents and they will form the shallow currents. So actually surface currents Deep currents and other surface currents are the types of major types of ocean circulation or ocean currents. Firstly, we will discuss how the surface currents are occurred. What are they actually? Surface currents are basically wind driven. The major role the pressure of wind has in the formation or distribution of that surface currents because of the wind pressure. They are primarily horizontal motion. Likewise, if you see in that sea, in that ocean area, you can imagine that the vertical motion can be like this one, but the horizontally they will surpass the other currents and they will form a swirl. What other types are the deep currents? They are driven by differences in density. As here you can see, as I have mentioned earlier in that start of that part, that cold and salty are deep currents, thus because of the temperature difference and also the salinity. This water is much saline and that cold then it will be dense and automatically in all atmosphere it will form the deeper currents, and it will be vertical as well as also horizontal motion. They can form both type of currents. It has been noticed, it has been observed that generally poleward, the currents that are towards the pole, either toward the north or the south pole, they are warm comparatively with general atmospheric temperature, and those are the adjacent waters of the oceans. Like if you see, we go towards the polar areas, the currents forming to the subpolar areas or towards the polar areas, they are warm because these transfer the cold water again towards that equatorial areas, and the equatorial water forms toward the subtropical or subpolar areas. So the equator moving current is cool because its temperature is lower than those of the atmosphere or of adjacent water. Why it cool? As I mentioned, and I will discuss here again and mention again as well, that the currents are the water, surface waters are the deep water. If that circulate from the polar toward that equatorial or polar the subpolar areas, that will obviously be cold because we know that polar areas are cool and coldest as compared to the equatorial areas. So these water will bring that water again towards that heated areas currents obviously will go towards the polar areas because of that circulation forming the temperature and pressure gradient, and due to these temperature differences, temperature will obviously distributed in the globe areas uniformly to form it in regulation and dynamic form. Other surface currents, these are the equatorial countercurrents that are in the control in the vertical form and in the adjacent counterly going towards the spiral form of the equatorial areas, and also the subpolar gyre style. As we know, the circular spiral world form and refers to the circular motion of water in the major oceans. Here I have mentioned it, I have given the graphical form of the Pacific Ocean. You can see the Atlantic Ocean, Indian Ocean, and other oceans here are discussed. If we see the north equatorial currents are here, the sea means currents, not equatorial currents, but if you see the equatorial counter currents, these are in the counterwise to the equatorial areas, but the sub equatorial counter currents are in that form adjacent and also opposite to the equatorial areas. If we look at the subpolar gyres are the smaller form of water, form of current of that water circulation towards the polar areas. These circulate like this and will come towards the polar area, subpolar areas, and are up to the equatorial areas as well. Here we see from the blue it means the cold or cold water, and from the red it means the hot water. If we observe the cool water coming towards the equatorial areas, and the warmer currents are going towards the polar areas to become again cool and again circulate the heat towards that equatorial area. The equatorial areas heat are surface heat is being regulated by that ocean currents towards the polar areas. So that's the system making other surface currents or other intensification of heat, which we are going to discuss in the next section. And thus the western intensification, the areas which fall toward the west of the globe, like we know west, east, north, and south. Western areas, to the west side of that equatorial areas, top yield of water displaced toward west. Why? Due to the Earth's rotation. Because we know the east-west wise rotation or the counter rotation of that will form the water displaced toward the west. Because of that surface load and rotation wise movement of the water. Western boundary currents are anticipated because of that rotation has a role in that. They will be faster, narrower, deeper, and will be warm. Comparatively to the eastern boundary currents, that's according in counter to that rotation of the Earth. They eastern are on the ocean basins. They have tend to the opposite properties of western currents. Likewise, if the western are the faster currents, they comparatively be much slower or slow currents. They will form a narrower belt over that surface oceans and our surface ocean towards the following water currents. They will be deep. They will be deep. No, so sorry. They will be shallow as compared to the western currents or western currents. They also will be cold as compared to the western intensification or the warm currents. That's why they are faster. If we see to the here to the examples are to the properties of that currents. If you see here the warm currents, then they are faster because they have low density. Here they have cold, they are obviously your currents and flow will be slow due to the density, high density. So these are the other currents. If we move toward the general factors that cause surface currents, what can be the major factors that are causing the surface currents? Now, firstly, which also I have mentioned before, is because of wind and its friction. The surface winds that blow over this surface and causing pressure and making the movement of that swirls or gyres and water currents. That is the main role in these surface currents to flow along that from one ocean part to the other global part of the oceans. Also the density, as I have mentioned before, the density of water is also has a role, because if the water is dense due to the salinity or other factors, it will obviously be deeper, follow or making deeper currents. And if the water is less dense, obviously it will be move faster and it will be warm as well, and it will be shallow currents. Atmospheric pressure along due to the temperature and also the precipitation is a role, because the precipitation and along with the winds and pressure along with the temperature gradient will make the currents to currents at the surface of the oceans. Melting of glaciers also is role, because melting of glaciers forming that kind of warmer currents towards the colder towards the subpolar areas or the equatorial areas, and making again the warm currents to flow towards the polar areas. Another factor that is very important and very major factor in that surface currents is the Coriolis effects or force. What's actually Coriolis effect or force? It's a function of latitude. It obviously will be maximum at the poles and minimum at the equator. If we see the polar areas like latitudinal base, the polar areas effect or force will be much, because the water will also be dense and it will follow towards the equator, and the swirls and the gyres will form utmostly. But in the longitudinal areas it will be not that much forceful. Another factor which I also have mentioned towards it, and is the temperature. Temperature is the role in that surface current formation, because temperature along with pressure is a role to form the currents or gyres and making the flow dynamic of the water from one surface of ocean to the other areas oceans. Gyres itself are larger loops of warming water Obviously I've discussed before, there's a main role in that surface conformation. Shape of the coast as well, because the more many coastal areas, their topography making the currents currents of processing the currents shape to become less or more towards the currents formation, and also the dynamic of ocean to become swirl or more vortex form. Seasonal change is discussed in that melting of glaciers. So seasonal change also has the effect. Also here have their point to be mentioned due to the moon effect, due to the moon nights or full moon nights also has effect on the ocean currents or surface ocean, and that's also been seen with the navigation purposes of the voyage of the heavy uh, vehicles in that oceans. Bottom topography, along with, if you discuss it with the uh, shape of the coast, it's the same, and these properties can be merged, and these are interrelated. Bottom topography along with the coast and topography is geographical factors also has the effect for the surface causing currents to be slower or much more faster. How ocean currents and climate are interrelated? What can be the major effect of these ocean or surface currents on this area, coastal area climate, and are the related area dry related area climate that are in the coastal areas, or are they are in the dry lands or highlands? What can be the effect of that climate? Firstly, if we see that image here I've shown in the warmer currents, if you see, that will move towards the polar areas. Here we have poles, mm, north pole and south pole, here the west and east. So if you go to that equatorial area, your warm currents are moving towards the polar areas, and the polar areas give us the cool currents because these are regulating that temperature. So here if we see it, the areas are the major countries forming here in America, you some in the America, these are the UA and KSA and the other Central Asian states here. Here the Russia and China, along with the Pakistan and these other Asian countries, and along with the European countries, and that South East Asian countries. So if you see, the warmer currents are near the coastal area of that um, Indian Ocean, along with the giving this kind of warmer currents again towards the polar areas, but the cold polar areas giving the colder currents again towards that coastal area. So it automatically will have effect due to the temperature and pressure gradient on that coastal areas and the climate of the areas which resides near the ocean coast, and also effect on the subregion areas. So if the warm ocean currents are there like this, the warmer air at coast will be obviously absorbed for these areas, and the areas which falls near the coast obviously feel that effect. As for example, in generalized form here, if we see that if Pakistan is somewhere there near to the coast, and the warmer currents are forming there, it will form the temperature and pressure, and obviously making the heat waves. What are the heat waves? That are the currents waves that forming towards the uh, area near the coast, and that if you see the example of Karachi, we observe the heat coast and the air pressure in that area, so making the warm air at that coast and that coastal areas. If warm humid air is there, humid climate and joining landmass will form. That's also the example. If you can, we can take the example of Karachi, that making the humidity so high that making the congestion that's heavy air, and also the pressure becomes so hot. And alternatively and comparatively, in contrarily, if the cool ocean currents are there, cool air at the coast will be formed is in some that colder areas. Cool dry air, if there is dry climate and joining land masses will be formed if we see the subtropical areas, sorry, subpolar areas near the near to the polar areas, sub dry climatic condition will form in that land masses adjoining to these areas. So that was about the ocean currents. their types and the major effects of the ocean currents on the climate of the coastal area.